Have you ever heard of microfiber shedding? It's when tiny little fibers fall off of materials like fabric or rugs, and scientists are finding them all over the world, even in human poop from people that live on every continent. At Waterlust, we make clothing, so we're contributing to this dilemma and have a responsibility to do everything we can to understand it and do something about it. As a company, we feel really strongly about communication and transparency, which is why we're making this video. But before we dive in, we're sure that people here, on the internet are going to be skeptical of the things that I might have to say. They might even suggest that I'm greenwashing. And although there's no real way for us to prove to you that we genuinely mean what we say, we're going to stick to the scientific method using peer-reviewed research wherever we can. So first, let's start with the history. Attention to microfibers evolved from work done on what are called microplastics, tiny pieces of plastic that have been found in increasing abundance in the environment. Studies have found microplastics in soil, water, sediment, and even in animal tissue. These findings have driven policy changes, like the Microbead Free Waters Act. Enacted in 2015 by Congress, it prohibits the manufacturers of rinse-off cosmetics that contain intentionally added plastic microbeads. This early work on microplastics led to the realization that fabrics made out of synthetic materials, like polyester or nylon, could be a source of plastic pollution also. In response to this, a variety of research has been done to examine the scale of the problem, and some of it's still ongoing. Millions of dollars were invested into research projects in the European Union in 2014 to examine microfiber shedding from clothing. And in a bold move to learn more, the outdoor clothing brand Patagonia funded research in 2015 at the University of California in Santa Barbara to try and quantify how many fibers were shed from everyday garments when being washed. Many other studies followed, and across the board the results have been pretty clear: fibers shed from fabric. Since this pioneering work that defined the problem, it seems like the focus has shifted to trying to find potential solutions, with different stakeholders offering different perspectives. To learn more about the current state of things, we needed an expert, so we got in touch with Dr. Myra McGuire. She has a PhD in marine biology and fisheries, and runs the Florida Microplastic Awareness Project.
All right, so Zoom is recording. So the Florida Microplastic Awareness Project, it began in 2015, in September 2015, and it has two components to it. One component is a citizen science aspect, where volunteers around the state have been collecting 1 liter water samples, originally just in coastal waters. The recent year or two, we've expanded into freshwater areas as well. And those volunteers filter the water, look at the filters under a microscope, and try to identify plastics that were in that sample. We combine that citizen science part with the outreach and education part. The concern is mainly focused around synthetic fabrics at this point, but the processes are true for both natural and synthetic. So when we wear fabrics, when we walk on carpet, when we sit on upholstered chairs, furniture, when we lay on sheets, when we launder clothing, the mechanical action breaks some of these little fibers off. And we know that at this point, pretty much wherever you look in the environment, the air, the ground, soil, the water, sediments, beaches, you're going to find a preponderance of these fibers. We know that with plastics in general, and synthetic fabrics are just a form of plastic, there are chemicals in the environment that preferentially adhere to, they stick to the surface of the plastic items. With these little tiny fibers, we've got a really big surface area to volume ratio, which means there's lots of real estate for these toxins to stick to. And in the water, there are a lot of these toxins that want to do that. It's a concern that these plastics in the environment could potentially act as vectors to transport some pretty nasty toxic chemicals. We often refer to them as persistent organic pollutants, or POPs. These include the polyaromatic hydrocarbons, the PCBs, the DDT family of pesticides. Because those toxins stick to the plastic and the plastic gets transported by ocean, wind, whatever kind of movement, The result could be that toxins get transported from one location to another and then get introduced into organisms that otherwise would not be exposed to them. At this point, nobody has looked at natural fibers and their impacts on organisms in the environment. And that is something that I've got a lot of questions about. We get all concerned about a synthetic fiber, but do we know if a cotton fiber is any less harmful to an organism that eats it? And at this point, we don't.
After speaking with Dr. McGuire, I was curious to examine how much our own clothes shed, like our leggings that are made from recycled bottles, but also wanted to compare them to a pair of cotton leggings of the same size. I needed a controlled environment, a space as free of contamination as possible. This is a huge issue in microfiber testing because fibers are present everywhere, even in the air we breathe. To wash our clothes in a controlled manner, I found some products from a company called The Laundry Alternative. They specialize in environmentally conscious laundry solutions, including a hand-cranked washer and a small high RPM dryer that would allow me to separate the two primary processes that occur in a modern laundry machine. These devices are also great solutions to reducing the carbon footprint of washing clothing, which is estimated to account for 2/3 of the overall carbon footprint of a garment, which includes manufacturing it. So if you truly want to go green, wash your clothes smarter. I began by washing each pair in 1 liter of cold water. I tumble washed each garment for 60 rotations, and after the washing was complete, drained the water into a clean holding container. Then I moved the wet clothing into the high spin dryer, allowing me to remove the majority of water left in the fabric itself. I filtered both samples with a 0.45 micron filter paper, using air pressure to suck the water through the tiny pores. Once the filtering was complete, I put the filter paper in a covered petri dish and took them to a high-powered microscope to examine. Looking at the filter paper with the naked eye, I didn't think there were any fibers present, but under magnification, they jump right out at you. The size of these things is hard to wrap your head around. They're too small to see with the naked eye, which is why most people don't even know they exist. Both the leggings made from recycled polyester and cotton both shed fibers, but what I didn't anticipate was that the dye used to color the cotton leggings black leached into the water during the wash and accumulated into the filter paper. This surprised me, especially since they are an older pair that had been previously washed multiple times. Both the sample from the tumble portion of the wash and the high spin drying portion had fibers present, but more tests are needed to statistically determine which process sheds more. Seeing the fibers under the microscope made me think that there must be some way of capturing them so they don't end up in the environment. So I went back to Dr. McGuire to learn more.
I think one of the biggest concerns in my mind with these fibers is we know that a lot of them are transported by air. And up until, I'd say, the last couple of years, we've really been thinking of the fibers as something that came through the wastewater treatment system. That when we laundered clothing or other textiles, the fibers would get knocked loose, they'd end up going through a wastewater treatment plant and being discharged in the effluent from that wastewater treatment plant. But what researchers are finding is that these fibers are showing up in really remote locations, remote mountain lakes that have no connection whatsoever to wastewater treatment plants. People have also done studies collecting rainfall and looking at what is in that rainwater, and they're finding these little fibers in there as well, along with some other small pieces of plastic, but the fibers are the predominant thing. I don't think the washing machine manufacturer route is necessarily going to address as much of the problem as people think it is. I have seen, I think, only one study so far that looked at release of microfibers from clothes dryers, and they found that they used fleece jacket and they washed it and then they put it in the dryer. And I think it was 3 times more fibers were produced in the drying process than in the washing process. So we've been ignoring clothes dryers, but it looks like they may be a bigger contributor. We've also got, if you think about things like carpet, how much carpet is there in the world? And most of it's made from synthetic stuff. And what do? We walk on it. So we're kicking up, I think about my office space here. We've got a lot of our offices are carpeted. So every day, we don't have a clue how many fibers we're kicking loose into the air, but I know that when I take a piece of new carpet and rub it over a petri dish and then look at that petri dish, there's a whole bunch of little fibers in there.
From your perspective, where do you envision solutions to this coming from? I've heard arguments to say this isn't the responsibility of the manufacturer and we should stop using synthetic fibers in clothing. Then I've heard arguments that there should be engineering of fibers to make them more the way that they're actually built on a molecular level. They should try to figure out ways to prevent that kind of mechanical detachment you discussed. And there doesn't really seem to be a consensus. And everyone seems to sort of be biased depending on what camp they live in.
Right.
You're a scientist, you are unbiased. What do you think? Where do you, if you had to be a fortune teller, where would you put your money and how we're going to solve this? I'm asking you all really hard questions. Sorry.
Well, so what direction would perhaps have the biggest chance of reducing microfibers in the environment? That's tough.
It seems obvious that all fabrics, whether clothing you wear or rugs you walk on, synthetic materials or naturally derived ones, shed microfibers. They shed when you wash them, when you dry them, and when you wear them. And although it makes sense that microfibers derived from plastic will degrade much, much slower than natural fibers, if I were a fish or a mollusk or even a human, I probably wouldn't want to ingest either of them. This seems to be where scientific research on the subject currently is. We know the fibers exist in the environment. We don't know what the biological impacts are. Because it's a super complicated issue, the topic of microfiber shedding tends to get oversimplified to make it easier for people to digest. But the dumbing down of a subject can be misleading and leave people feeling like they understand a subject that they actually don't. At Waterlust, we're committed to making clothing using the most environmentally responsible processes that exist. But that doesn't mean we don't do any harm. That's the problem with making most things. There's always an environmental downside. Take electric cars, for example. They reduce our dependence on oil, which is great, but they also require a lot of lithium for batteries, which is a non-renewable resource that harms the environment when harvested. As it relates to clothing, some argue that natural fibers like cotton are the solution to everything, and that they should only be grown organically. But this ignores how organic farming of row crops tends to produce smaller yields. Meaning, if we wanted to switch all of our farming in the United States to organic, it would require approximately 109 million more acres of agricultural land, equivalent to all the park and wildlife land in the lower 48 states. The point I'm trying to illustrate is that environmental problems are complicated. There's always a downside, and our thirst for simple, easy solutions can cloud our judgment. Going back to microfiber shedding, as a company, it's something that we definitely think is bad, and we're not proud that we're contributing to it. However, it is only one part of a much bigger environmental picture. When you consider the environmental impact of any product, you have to look at its full life cycle, or as we describe it, its birth, its life, and its death. Birth relates to how many resources it requires to produce a product, like electricity, water, and agricultural space. And on the scale of environmental goodness, recycled materials are far and away the best because they utilize an existing resource that exists in huge quantities. Approximately only 10% of plastic globally has been recycled, which makes you wonder, why are we making more plastic when we have so much just laying around everywhere? Virgin materials, whether synthetic that are derived from chemicals or natural that are grown in the ground, need to be created from scratch, which requires raw materials, energy, water, agricultural space, the list goes on. And because of all of that, they have a bigger birth footprint. But that's just birth. In the life category, we assess how well the material serves its job and how long a garment will last. Replacing your clothing every season comes with added environmental costs, so building something that will serve its function for a long time helps reduce impact. The product itself must also perform its function as well or better than the competition in order for the average consumer to purchase it. If an environmentally friendlier solution succeeds, the approach may then become widely adopted within an industry, which is hugely beneficial for the environment. Going back to the electric car metaphor, Tesla isn't successful because they make electric cars. They're successful because they are making the best and safest cars in the world that just happen to be electric. Finally, in our life cycle analysis is the death category. What do you do with your clothes when you're done? And statistically, for 75% of you, the answer is that you throw it away and it ends up in a landfill. This is where synthetic fabrics score poorly, because unlike a natural fiber that can biodegrade, synthetic materials stick around for a long time. And some might argue that recycled materials would have ended up in a landfill anyway, and that we're simply diverting that journey, but it still doesn't feel right to know that my clothing buried in a landfill is going to be on this planet long after I die. So where do we go from here? Our waterware lifecycle analysis reveals pros and cons of each approach. For recycled synthetics, reduced carbon emissions, minimum water use, non-leaching dyes, and no agricultural land demands are good, while plastic pollution through microfiber shedding or end-use disposal in a landfill is bad. A natural fiber like cotton requires more energy and resources to produce, it performs its function worse, which is all bad, but the material itself is biodegradable, which is good. So environmentally, which option is better? That's a really difficult question to answer, but for now, we think recycled synthetics are better. But it's important to recognize that recycled materials aren't perfect, and making clothing out of them isn't as environmentally friendly as it could be. It's a good starting point, but not the finish line. Going back to the electric car metaphor, outfitting every car on Earth with lithium-ion batteries may not be physically possible. We may just run out of the stuff. But does that mean we shouldn't produce electric cars with it today as a stepping stone in the right direction? The same argument can be made for oil. It pollutes and warms the planet, which is bad. But in the late 1700s, when the internal combustion engine was invented, it was a technological marvel that enabled us to stop riding horses. Today, we think making clothes with recycled materials makes sense from a life cycle perspective, but we're going to continue to try and find better solutions. One idea we're trying to launch later this year is a closed-loop recycling program, where our customers can send back their old clothing to be downcycled into new clothing. This could prevent any of our clothes from ever ending up in a landfill, though it still doesn't address the microfiber shedding issue. For that, as frustrating as it is to admit, we don't have a fix-all solution. But just because we haven't figured it out doesn't mean we're giving up. Some emerging technologies that have promise include polyhydroxyalkanates, or PHA, a special kind of polyester derived from bacterial fermentation of sugar. This kind of polyester is created naturally within a microorganism as an energy reserve, meaning it gets eaten up naturally in the environment. This won't prevent fibers from being shed in the first place, but when they do, they won't last very long. The downside is that the technology is still young, and PHA isn't commercially viable as an apparel fiber yet, but in a few years, we reckon it will be. Another concept that we've been working on is referred to as a biodegradable additive. In this approach, a small piece of microscopic food is chemically bonded onto one end of the synthetic polymer. The food attracts naturally occurring microbes that then apparently eat up the remaining polymer chain, kind of like Pac-Man. The upside is that it should be able to be applied to a variety of recycled plastics without the material losing its performance characteristics, while the additive allegedly makes it energetically favorable for biodegradation in landfills and in the marine environment. A few companies are already advertising some commercial products using this concept, but none, in our experience, have provided sufficient peer-reviewed results that verify their biodegradation claims. And as much as we want to trust what other companies tell us, the scientific method requires verifiable and replicable results before something can be considered as fact. And finally, we haven't given up on natural solutions and continue to test materials like bamboo, hemp, and recycled cotton. So far, none of them have performed the way we need them to, but we'll keep pushing and experiment. In the meanwhile, reducing your contributions to microfiber shedding is difficult to do, but our research suggests the following steps may help. Don't wash your gear unless you have to. Our fabric is woven in such a way that it reduces microbial absorption. Or in other words, it won't smell that bad after you wear it. Also, the colors won't fade, even if used in salt water or chlorine. So a quick dunk in fresh water is really all it needs. Violently tumble drying our clothes is unnecessary and will likely lead to more fibers being shed. Another idea is to skip the dryer altogether. One of the reasons we really like synthetic materials for waterwear is because it dries really fast. And since it sounds like dryers are potentially a bigger source of microfiber shedding than a washing machine, you'll be taking an even bigger bite out of your fiber footprint by line drying in the sun. And finally, we want to know what you think. What ideas do you have to help make clothing more environmentally friendly? Join the conversation in the comments below, and I will personally respond to each and every one of them. The Waterlust community, you guys, is this amazing community of intelligent people all around the planet, and we want to hear and learn from you.